Welcome to clickmyproject.com. Yeah, let us discuss about the Quantized Massive Multi-User MIMO-OFDM Uplink. Yeah, let us discuss about the abstract of the product. So the core is quantization and the base station of a massive multi-user. So that is a MU, multiple input and multiple output wireless. That is a wireless cost of services. System promises significant power and cost savings. So chorus quantization also enables significant reducing of the raw, so analog to digital converted data that must be transferred from a spatially separated antenna array to the base station processing unit. So the theoretical limits as well as a practical transfer algorithm for such quantized multi-user MIMO systems operating over frequency flat narrowband channels have been studied extensively. However, the practically relevant scenario where such communication systems operate over frequency selective wideband channels is less well understood. So in this paper, investigate the uplink performance of quantized massive MIMO system that develops orthogonal frequency division multiplexing for wideband communication. So in this proposed work, uplink performance of quantized massive multi-user multiple input and multiple output system that deploys the orthogonal frequency division multiplexing for wideband communication. So we propose a new algorithm for quantized maximum posterior channel estimation and data detection, and we study the associated performance quantization trade-offs. So our results, finally the core is quantization, for example 4 to 6 bits depending on the ratio between the number of base station and number of the users. So in massive MU-MIMO-OFDM system, virtually no performance loss compared with the infinite precision case at no additional cost in terms of baseband and also processing the complexity of the process. Yeah, let us discuss about the flow diagram of the process. So first of all, we are using the system model and then robust MIMO design. So that is a multiple input and multiple output design, and then multi-user MIMO. So that is a multi-user MIMO, multi-user and also a multiple input. So finally, the extension to multi-user MIMO systems, and also finally performance analysis. That is a BER and MSE of the performance. So the core is quantization at the base station of the massive multi-user. So the multiple input and multiple output wireless systems promises significance, power and cost savings of the process. So whatever it may be, here using the MIMO design of the system. So convert the data that must be transferred from a spatially separated antenna array to the baseband processing unit. So here we using the particular process that operating over frequency flat narrowband channels have been studied, such as the communication systems operate over frequency selective wideband channels is less well understood. So in this particular value, the extension to here we using the MIMO concept. So multiple input in the transmitter side, multiple antennas will be used, and then the receiver side also here we using the multiple antennas. Finally calculating the particular value and then for the multi-user systems. Yeah, so in this robust MIMO relay design to develop two iterative algorithms. So that is namely called tri-step and bi-steps algorithm to optimize the source and relay receive matrices. Basically, the concept for the optimize the problem. So optimize the scheduling is the important process in the MIMO concept. So in the tri-step algorithm, the source, relay and receive matrices are optimized iteratively through the solving the convex of the subproblem of the process. So whatever it may be, here we using the MIMO, it's the best process. Finally, in the performance analysis process, bit error rate and MSE of the process. So to study the performance of the proposed robust source and relay pre-coding matrices designs algorithm for multi-users MIMO relay system with source and destination links, imperfect CSIs through the process of simplicity to consider a system with two users where all the nodes are equipped with multiple antennas as defined as the signal to noise ratio, that is called as SNR. So in the SNR for the source, that is a I relay destination and also a source I destination links. So the whatever it may be, to compare the BER and MSE performance of all the algorithms will data SNR is equal to 20 dB of the process. So whatever it may be, the values will be calculated. So the performance analysis is calculating BER and MSE of the process. So bit error rate and minimum mean square error of the process. So these are the overall flow diagram of the particular process. Yeah, let us discuss about the running procedure for the product. So click the main file and then run. So all the outputs are displayed. So like that, quantized output like that. So all the outputs are displayed. Yeah, similarly I will describe one by one. So first of all, this is the transmitted data. The transmitted input data. So I will check it. randomly selected transmitted input data. So the data points, these are transmitted data and represent the phase of randomly generate the input data of the process. So this is the first figure, and then in the next figure, so modulated data. Here we using the QAM modulation, that is a quadrature amplitude modulation, to modulate the transmitting data by using the QAM modulation. This is the data points and transmitting modulated data by using the modulation data transmission of the points. So in this next figure, this is a quantized, it's in the pilot channel estimation. So whatever the pilot channel estimation, so pilot channel will be calculated. The values are displayed in the table. So that is a pilot channel estimation. And then in the next figure, so that is a OFDM signal. By using the transmitted bits, generating the OFDM signal, that is a orthogonal frequency division multiplexing signal to calculator. So this is the time and this is the amplitude of the process. So generating the OFDM signal by using the, then only the processing easily should be calculated the process of the particular process. So in the next figure, this is the original versus quantized signal. The blue line indicate the original signal, the red line indicate the quantized signal. So this is the difference between original and quantized signal of the process. The next figure, this is the quantized signal values. So these are the values will be displayed in the quantized signal that will be calculated by using the particular value. So this is the original and quantized signal of the process, and this is the values of the particular quantized process. The next figure, that is a trade-off between the so trade-off between the SNR and quantization width. So this is a mismatch 1 MMSC, so that is a minimum mean square error, and quantizer MMSC, so that is a minimum mean square error. So this is a red line and then blue line. So quantized bits of QB, and this is the minimum SNR of the value. So 0 to 25, so this is the minimum SNR, and trade-off between the SNR and quantization bits of the process. In the next figure, so the trade-off between the SNR and quantization bits, mismatch 2 and the MMSC, and then quantizer MMSC of the process. So this is the same process. So the Y indicate the quantization of QB, and then X indicate the minimum SNR of the process. So quantize M9 and mismatch 1 and mismatch 2 of the process. So these are the two different graph. And then the next figure, so the outage probability comparison between different decoding scheme. So in MU-MIMO concept, outage probability is must. So this is the outage probability of the graph. So SNR and outage probability, it should be minimum. So the ping, it should be minimum 10 power minus 4 of the process. And then the next figure, bit error rate comparison of QA modulation with different decoding scheme. So 10 power minus 1, this only minimum to reducing the error rate for the SNR and BER scheme. So these are the overall running procedure for the process. Thank you for listening this video.